host-microbe interactions, and epidemiology. Acquired immunity, active versus passive, natural versus artificial. Keep in mind who and where the immune factor is made. That will help you to distinguish active, passive, natural versus artificial immunity. If we have acquired active natural immunity, active means you made the immune factors. Natural simply means as part of everyday living. You accidentally get exposed to a pathogen and you got sick. Active acquired artificial immunity. Active, again, your body made the immune factors. Artificial means we've deliberately introduced a pathogen or part of a pathogen into you. So we deliberately exposed you to some piece or portion or a whole microorganism. In other words, you are immunized, or also called vaccinated. So active natural, you get sick. Active artificial, you got an immunization. Acquired passive immunity. Passive means someone else made the immune factors and they were transferred to you, either through natural process or deliberately. Acquired passive natural immunity. A good example are maternal antibodies that are transferred to a baby through the placenta during pregnancy, or to a newborn or to a baby through mother's milk. Colostrum is the first discharge that comes from mammary glands shortly after delivery, maybe for about 48 to 72 hours. It has a different consistency, and it also has a more rich source of vitamins, minerals, fatty acids, and immune factors. Acquired passive artificial means that someone else took the time to formulate and extract immune factors from some source, and then they were deliberately injected or infused into a recipient or patient. So, gamma globulin is a good example that's been used for many years. Antitoxins are antibodies directed against toxins. RhoGAM, if you've ever heard of a blood incompatibility or ABO incompatibility or RH incompatibility between mother and baby, especially for RH, we do have antibodies that can be given to the mother to prevent the mother's body or her immune system from essentially attacking the baby if she has, or the baby has, different RH blood types. Passive natural, mother to child, passive artificial, a wide variety of sources of antibody to anyone, either through injection or infusion. Now, what if you haven't had any exposure to a pathogen? What if you haven't been immunized? Well, there is such a thing as herd immunity. It could be possible that you could reap the benefit of those around you already being immune to disease. For example, here we have an illustration of 10 people, and out of those 10, one person is immune, one is infected, and the remaining are susceptible. Well, since only 10% of the population is immune, that leaves the other 80% who are susceptible quite vulnerable. That one person who is a source of infectious material or pathogen could essentially encounter almost everyone in the susceptible group and make them sick. What if our herd immunity has 50% of the population immune? That means it's less likely that you would encounter that one source of infected material. So you could benefit even if you're susceptible to the majority of individuals around you already being immune without having had the appropriate proper type of immunization. What if 90% of the population is already immune? That's definitely going to give an individual a great deal of protection. Take a look at the graph at the bottom. Over a period of time, if that one person out of the 10 that we are illustrating does get sick, there's not the impact to productivity that would happen in comparison to if only 10% of the population is immune. Go back through the slides and take a look at the graphs on each page or each slide and notice the distinct difference in number of cases over a period of time when we have 10% versus 50% versus 90% population immunity. There's a huge dramatic difference. The more individuals in a population that are immune, the safer it is for all of us. In terms of immunization, what kinds of materials can be used to provide acquired active artificial immunity? Well, vaccines come in forms of toxoids. Toxoids are toxins that have been inactivated so that they're no longer dangerous, but instead simply immunogenic or capable of stimulating the immune system without causing disease. We can have vaccines made of killed microorganisms, such as the Salk polio vaccine. We can have live attenuated or weakened vaccines, like the Sabine polio vaccine, which is an oral vaccine. We can have purified antigens, like the pertussis fraction that's now in the DPA. We have routes of administration that differ from intramuscular to subcutaneous. Now we have various uses of passive immunity in terms of antibodies, such as antitoxins and gamma globulin. There is such thing as a vaccine court. The vaccine court is essentially in the Court of Federal Claims that provides a mechanism for compensation in case there is a serious adverse effect due to a vaccine. The CDC posts a good bit of information about vaccine court, and Health and Human Services does as well. So you can find quite a bit of information now on the internet and links to important agencies that help with vaccine and vaccine adverse effects. Historically, two individuals were very important in the formulation of polio vaccines. You hardly ever hear of polio anymore, and in fact, it's one of the diseases that may be shortly, hopefully, completely eliminated from the human population. Two individuals we have to thank for those goals are Jonas Salk, who developed the first polio vaccine, which is a killed poliovirus formulation that's an injectable, and Albert Sabine, who developed the oral polio vaccine, which is a live, attenuated vaccine strain of the virus. The combination of using both of these vaccines have successfully allowed us in Health and Human Services and public health to eliminate polio or reduce polio dramatically in the United States, and the World Health Organization has overseen the elimination and reduction of polio cases worldwide. Even though there's always some risk when any type of healthcare procedure or medication is used, typically for vaccines, the risk is very minimal and the benefit is huge. Take a look at these four small graphs that illustrate the tremendous decrease in prevalence of diseases like polio, diphtheria, smallpox, and typhoid when vaccines were implemented to control these diseases. In fact, by 1980, smallpox was totally eliminated from the face of the earth in terms of causing disease. Other diseases, polio, diphtheria, and typhoid, have also dramatically decreased in prevalence worldwide because of vaccines.